this episode, we start with a part of cybersecurity that sounds quiet and administrative at first, but it becomes very important once you realize how many real security problems begin with old technology that nobody fully owns anymore. Every organization depends on hardware, software, cloud services, user devices, and supporting systems that all age over time, and none of them stay current forever. At some point, products stop receiving updates, support ends, replacement becomes necessary, and the risk of keeping them around begins to rise. That is why asset lifecycle management matters so much. It is the practice of understanding where assets come from, how they are used, how they are maintained, when they become risky, and how they are replaced or retired before they turn into weak points. For beginners, this topic is important because security is not only about stopping attackers in the moment. It is also about making sure the environment does not slowly become unsafe just because aging software and devices were allowed to remain long after their safe and supported life ended. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.me in the Bare Metal Study Guide series. An asset lifecycle is simply the full span of an asset's existence inside an organization, from the moment it is selected or acquired to the moment it is removed, replaced, or securely disposed of. An asset can be a laptop, server, application, network device, mobile phone, virtual machine, printer, or even a cloud-based service that supports business operations. The important idea is that every asset has a life story. It enters the environment for a reason. It serves a purpose for a period of time, it needs maintenance while it is in use, and eventually it becomes outdated, unsupported, or no longer appropriate for the organization's needs. Security depends on understanding that story because risk changes over time. A device that was perfectly reasonable 3 years ago may be a serious concern now if support has ended, patches are no longer available, or the business has forgotten how important that device still is. Lifecycle management keeps security teams from treating technology as static when the real environment is always changing. One of the key phrases in this episode is end of life, EOL, because that is the point where a product is no longer intended to continue in normal supported use. Sometimes EOL means the manufacturer stops selling the product. Sometimes it means technical support ends. Sometimes it means software updates and security patches are no longer provided. The exact meaning can vary, which is why organizations need to pay close attention instead of assuming every old asset is still covered simply because it continues to function. A beginner mistake is to think that if a device still turns on or an application still runs, then it remains safe enough to keep using. That is not how security works. Functioning is not the same as being supportable, observable, or defensible. Once an asset reaches EOL, the organization may lose access to fixes, vendor guidance, compatible tools, or practical recovery options, and all of that increases the risk of keeping the asset in place. The reason EOL software and devices matter so much in security is that attackers often benefit from systems that have stopped improving while the threat landscape keeps moving. New weaknesses continue to be discovered, but old products may no longer receive protections against them. Even if the asset has not yet failed, the organization may be relying on technology that has become easier to misuse, harder to monitor, and more difficult to integrate into modern security practices. In some cases, the system may lack support for stronger authentication, current encryption, safe logging, or modern management features that make security operations easier. In other cases, the asset may become difficult to replace because it still supports an important business function and nobody wants to interrupt that function. That is where lifecycle management becomes a true security discipline. It forces the organization to confront the reality that old assets do not become risky all at once in a dramatic moment. They often become risky slowly, through neglect, delay, and the false comfort of thinking that continued use means acceptable use. A strong way to understand lifecycle management is to see it as a series of decisions rather than a warehouse list of equipment. Before an asset is even introduced, the organization should think about why it needs that asset, who will own it, how long it is expected to remain useful, what data or systems it will touch, and what happens when support eventually ends. During active use, the organization should understand how the asset is configured, what updates it requires, who is responsible for maintenance, how it is monitored, and whether it continues to meet security expectations. Later, the organization should evaluate whether the asset is nearing obsolescence, whether replacement planning is underway, and whether dependencies will make retirement difficult. Finally, when the asset is retired, the organization should ensure data is handled properly, access is removed, and the old technology is not quietly left behind in a forgotten corner. This kind of thinking helps security become proactive instead of reactive. Visibility is one of the most important foundations of this entire topic. An organization cannot manage life cycles well if it does not know what it owns, where those assets live, what they run, who uses them, and how important they are to operations. That may sound obvious, but many security problems grow out of incomplete visibility. A forgotten server, an old application on a rarely used workstation, an abandoned cloud resource, or a legacy network device in a remote office can remain in use far longer than anyone intended simply because nobody has a complete picture. Once visibility is weak, lifecycle decisions also become weak. Teams may miss vendor notices, overlook dependencies, or fail to recognize that a critical business process still relies on something that is nearing EOL. Beginners should understand that asset inventory is not just an accounting exercise. It is the starting point for security awareness. If you cannot clearly see your assets, you cannot confidently manage their age, risk, support status, or replacement needs. Ownership is another essential part of lifecycle management because assets tend to become dangerous when everyone assumes someone else is responsible for them. A device may physically belong to one department while being administered by another and relied upon by a third. A business application may be purchased by one team, configured by another, and barely understood by either after the original staff members leave. When nobody clearly owns the asset, update decisions are delayed, replacement planning fades, and EOL warnings may be ignored until the situation becomes urgent. Good lifecycle management gives each asset a clear accountable owner, even when multiple groups are involved in maintaining or using it. That owner does not have to do every task personally, but there must be a clear line of responsibility for making sure the asset remains supported, secure, and visible in planning conversations. This matters because cybersecurity problems often persist not through technical complexity alone, but through simple ambiguity about who is supposed to act. Software life cycles deserve special attention because software often remains hidden behind business convenience. People see devices every day, but they may not think as much about the age and support status of the applications running on those devices. An old operating system, OS, a legacy database, a business-critical custom application, or a browser plugin that once seemed harmless can all become serious issues when support ends or compatibility breaks. Sometimes organizations delay upgrades because the software still supports an important workflow, and they worry that change will interrupt operations. That concern is understandable, but delay has its own cost. Unsupported software may stop receiving security fixes, may not work well with modern controls, and may create fragile dependencies that become harder to unwind with each passing year. From a beginner standpoint, the lesson is simple. Software ages just as much as hardware does, and because software often touches identity, data, and business logic directly, its life cycle can carry just as much security significance as the devices that host it. Devices create their own life cycle challenges because hardware tends to remain in use for practical and financial reasons even after it has become hard to defend properly. A router, server, printer, laptop, firewall, badge reader, scanner, or industrial controller may still perform its basic task long after its secure life has become questionable. In some cases, the device cannot support current protections. In other cases, the vendor stops releasing firmware updates or replacement parts. Sometimes the device sits in a remote or specialized environment where change is inconvenient, so teams postpone the decision again and again. That is how legacy risk builds. A device becomes normal simply because it has been present for so long. Beginners should understand that hardware security is not just about whether the equipment is physically intact. It is also about whether the device can still be managed, updated, monitored, authenticated, and trusted in a modern environment. Once those qualities begin to fade, the lifecycle discussion becomes urgent even if the device still seems useful. A major challenge in lifecycle management is dependency, because organizations rarely replace one asset in isolation. An older application may depend on a specific OS version. A specialized device may require an older management console. A line of business process may rely on a legacy server that nobody wants to touch because too many downstream systems depend on it. This is where beginners learn that cybersecurity is often tied to architecture and operations, not just individual components. Assets form relationships, and those relationships can trap organizations into keeping outdated technology longer than planned. Good lifecycle management tries to discover those dependencies early. It asks what systems, users, vendors, and workflows will be affected if this asset changes or disappears. That kind of thinking helps the organization avoid last-minute crises where a critical asset reaches EOL, and only then does everyone realize how deeply it is tied into daily operations. Security improves when replacement planning starts before the dependency problem becomes an emergency. Another important lesson is that lifecycle management is not always about immediate replacement. Sometimes an organization cannot remove an EOL asset right away because of budget limits, operational dependencies, or the time required to migrate safely. In those cases, risk still has to be managed. That may mean isolating the asset more carefully, reducing the number of people who can access it, limiting its network exposure, increasing monitoring, tightening surrounding controls, or developing a clear short-term retirement plan with executive visibility. These kinds of measures are often called compensating controls, and they matter because security work must deal with reality rather than fantasy. A perfect answer is not always available immediately. What matters is whether the organization clearly understands the risk and actively reduces it while moving toward a stronger long-term state. Beginners should not assume that keeping an old asset is always reckless or that replacing it instantly is always realistic. The real question is whether the organization is making informed, controlled decisions instead of ignoring the problem. Lifecycle management is also closely tied to budgeting and planning, which is another reason it belongs in security conversations instead of being treated as someone else's operational concern. If leaders only think about assets when they break, replacement becomes reactive and rushed. If they understand that hardware and software have predictable aging patterns, then security, operations, and finance can plan refresh cycles more intelligently. That planning reduces the number of surprise decisions, reduces emergency purchases, and lowers the chance that unsupported technology remains in place simply because nobody reserved the time or resources to replace it properly. For beginners, this connection is important because it shows that strong cybersecurity is not only about technical defense. It is also about organizational discipline. When lifecycle planning is ignored, security teams are often left defending environments that have become harder and harder to protect. When lifecycle planning is taken seriously, the organization creates a healthier foundation where supportable technology remains the norm instead of the exception. Retirement and disposal are the final parts of the life cycle, and they matter just as much as acquisition and maintenance. An asset that is no longer used still creates risk if data remains on it, credentials are still attached to it, or network connections continue to trust it. A retired laptop, server, storage device, or cloud resource cannot simply disappear from attention once daily use stops. The organization needs to make sure data is removed or destroyed appropriately, access rights are revoked, records are updated, and the asset no longer appears as a hidden path into the environment. This stage is often overlooked because people are relieved simply to move on from old technology, but careless retirement can undo much of the benefit gained from replacement. Beginners should remember that ending use is not the same as completing the life cycle. The life cycle is only complete when the organization has securely closed the loop and made sure the old asset no longer carries useful data, trust, or exposure into the future. A common misconception is that lifecycle management is mostly about large enterprises with huge asset inventories. In reality, organizations of every size benefit from understanding what they own when it ages out and how to deal with EOL technology before it becomes a problem. Another misconception is that asset age alone tells you everything you need to know. Age matters, but so do support status, exposure, data sensitivity, business dependence, and the ability to apply modern controls. A third misconception is that lifecycle work belongs only to operations teams. Security has a direct stake in the issue because unsupported and unmanaged assets often become some of the hardest systems to defend. When beginners understand these points, they begin to see lifecycle management as a shared responsibility that connects governance, budgeting, architecture, operations, and day-to-day security thinking. That broader view is useful because it explains why seemingly routine asset decisions often carry much larger security consequences than people first expect. As we close, the main lesson is that managing asset life cycles well helps organizations avoid the slow buildup of risk that comes from letting old software and devices linger without clear support, ownership, or retirement plans. EOL technology matters because it often remains functional while becoming harder to patch, harder to monitor, and harder to trust. Good lifecycle management creates visibility, assigns ownership, tracks support status, recognizes dependencies, plans replacement early, applies compensating controls when needed, and completes retirement carefully so old assets do not continue creating hidden exposure. For a beginner, this topic is a powerful reminder that cybersecurity is not only about dramatic attacks or urgent response. It is also about managing the ordinary aging of technology with enough discipline that the environment stays supportable and defensible over time. When organizations take asset lifecycle seriously, they reduce avoidable weakness and create a much stronger foundation for everything else security teams are trying to protect.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.